And this is Miss Humbert here. Today we're going to be doing Unit 9, Note 6. We're going to be talking about factoring with excluded values. So let's go ahead and let's just kind of jump right into it here. So first of all, let's just kind of review factoring. Now, earlier in this unit, we talked about a new way of factoring in that if the coefficient with the squared term is 1, which it is here, we can immediately put things into factors. So we're going to take 1 and we're going to multiply it by the 5. Well, 1 times 5 is 5. So we're multiplying to 5 and adding to 6. So then we need to ask ourselves, what multiplies to 5 and adds to 6? Well, that's just going to be 5 and 1. So because that coefficient in front of the squared term is 1, we can immediately write it as x plus 5, x plus 1 into factored form. So this right here is the factoring for number 1. Now let's take a look at number 2. So for number 2, again, your coefficient with the squared term is 1. So we're multiplying to negative 18 and adding to negative 7. So we have negative 9 and positive 2. So again, we can immediately put it into factored form. So I have x minus 9. Now notice that I'm taking the sign with it, and then x plus 2. So that's your final answer for number 2. So let's talk about factoring with excluded values. Sometimes when you find the excluded values, there's a quadratic on the bottom. Now remember that quadratic means that there is that squared term. So once you factor, the zero product property will give you the excluded values that you need. That's kind of what we did on the previous note. She was finding those excluded values. So let's go ahead and let's take a look at some examples. So taking a look first at number 1. So what we need to do to get the excluded values, we know that that denominator is going to be set equal to 0. So we have x squared plus 6x plus 8 is equal to 0. So now, in order for us to figure out when x is going to be equal to 0, we have to factor. So notice that our coefficient is 1, so I can use that easy factoring way. So 1 times 8 is 8. So you're multiplying to 8 and adding to 6. Well, what multiplies to 8 and adds to 6? That's going to be 4 and 2. So I can immediately put this into factored form. So I have x plus 4 times x plus 2. Now recall that that's equal to 0. So the next thing we're going to do is set each of those factors to not equal 0, right? Because we don't want it to equal 0, because then our denominator will equal 0. So here I'm going to subtract 4 from both sides. So I get that x cannot be negative 4 as one of my answers. Subtract 2 from both sides, and x cannot be negative 2. So those are your two answers for number 1. Let's take a look now at number 2 and factoring that one. So again, x squared minus 5x plus 6 cannot be equal to 0. So when we're setting that up, we're multiplying to 6 and adding to negative 5. So we want to have two negatives. So that's going to be negative 3 and negative 2. So then we're going to split up that negative 5x. We get negative 3x minus 2x plus 6, and that cannot be equal to 0. Oops, I forgot that you can use the easy way. So because our coefficient is 1 here, we can use easy way, which is x minus 3, x minus 2 cannot equal 0. So x minus 3 is not equal to 0, and x minus 2 is not equal to 0. So then here, you're going to add 3 to both sides, and you get that x cannot be 3. And here, add 2 to both sides, and you can get that x cannot be 2. So we get x is equal to 3, and x is equal to 2 for our final answer for number 2. Let's take a look at number 3 and number 4. So we're going to, again, set up the bottom for factoring. So I have x squared minus 10x plus 16 cannot equal 0. So again, I can immediately set up my x, 16, so we're multiplying to negative 16, or positive 16, and adding to a negative 10. So since I have a positive product, both my signs have to be the same, and we're adding to a negative sum. So that's going to be negative 8 and negative 2. Again, I can use easy way factoring, which is x minus 8, x minus 2, and that's not going to be equal to 0. So x minus 8 is not equal to 0, and x minus 2 is not equal to 0. So here I'm going to add 8 to both sides. And then once I add 8 to both sides, I end up getting that x cannot be 8. Here, add 2 to both sides, and I get that x cannot be 2. So x is not equal to 8, and x is not equal to 2. Next, taking a look at number 4, same thing, x squared plus 5x minus 6 cannot be 0. So now we're setting this up. So we're multiplying to negative 6 and adding to 5. So that's going to be negative 2 and positive 2. Whoa, Miss Humbrick, come on. So we're multiplying to a negative 6 and adding to a positive 5. So what I actually need to use is positive 6 and negative 1. So again, this is a 1, so I can immediately put it into factored form. So x plus 6, x minus 1, and that's not equal to 0. So then I get x plus 6 is not equal to 0, and x minus 1 is not equal to 0. So then I'm going to go ahead and I'm going to subtract 6 from both sides. So I get that x is not equal to a negative 6. Here I'm going to add 1 to both sides, so I get that x is not equal to 1. So I have both of those right there. Okay, so let's talk about if they cancel out. So you can cross off the values that overlap. However, when we are crossing off factors that overlap, your excluded values still need to come from the original denominator. So let's go ahead and let's take a look at what that would look like. So for starters, on that first one, we need to factor out that bottom, the denominator. So I need to factor out that x squared plus 3x plus 2. So I'm multiplying to 2 and adding to 3. So that's going to be 2 and 1. So then let's take a look at what that gives us. So then we have x plus 2 divided by x plus 2 times x plus 1. Now, you can only cross off when you are dealing with multiplication. So since we are dealing with multiplication here, you'll notice that this is multiplied by this. We can actually cancel out those x plus 2's. So then I'm going to have a 1 left on the top because I can't just get rid of my top. So I have a 1 left on top, and then I have x plus 1 on the bottom. So that's that reduced form, but we're actually today talking about that excluded values. So when I go to calculate out the excluded values, I still need to use that original version. So I'm going to take x plus 2 times x plus 1, and that cannot be equal to 0. So x plus 2 is not equal to 0, and x plus 1 is not equal to 0. So now we're going to solve each of those. Here, subtract 2 from both sides, so you get that x cannot be negative 2. Here, subtract 1 from both sides, and you get that x cannot be negative 1. So that's your final answer for that one, for those excluded values. Now let's take a look at number 6. So we're factoring, and we're multiplying to negative 35 and adding to 2. So that's 7 and negative 5. So again, and for the most part in the unit, the coefficient with the square term is going to be 1. So for the majority, you can use the easy way factoring. So then I end up getting x plus 7 on top, divided by x plus 7 times x minus 5. So again, I can cross off those x plus 7s. That'll make it a little bit easier on me. However, my excluded values need to come from the original. So when I cross those out, I'm left with 1 divided by x minus 5, because we can't just have the top disappear. The top's going to become 1. So now I'm going to set x plus 7 and x minus 5 equal or not equal to 0, okay? So x plus 7 cannot equal 0, and x minus 5 cannot equal 0. So for this first one, I'm going to subtract 7 from both sides, and I get that x is equal to negative 7. And then, taking a look at that next one here, we're going to set that minus 5 equal to 0. So here we're going to add 5 to both sides, and I get that x cannot be 5. So x is not negative 7, and x is not 5. All right, so let's take a look at number 7 now. So for number 7, we're going to factor. So I'm multiplying to 12 and adding to 13. So what multiplies to 12 and adds to 13? Well, that's just going to be 12 and 1. So I end up getting x minus 3 divided by x plus 12 and x plus 1. Well, guess what? There's no factors we can cross off, but it doesn't really matter because when we do our excluded values, we always have to look at the original. So x plus 12 and x plus 1 is not equal to 0. So x plus 12 is not equal to 0, as well as x plus 1 is not equal to 0. So now we're going to solve these here. Subtract 12 from both sides, so you get that x cannot be negative 12. Here, subtract 1 from both sides, so you get that x cannot be negative 1. So I have negative 12 and negative 1 on number 8. Or number 7, sorry. Now let's take a look at number 8. So for number 8 here, scroll back up, we're going to factor that top. So I'm multiplying to 10 and adding to negative 7. So again, positive product, negative sum. So both my signs need to be negative. And I'm going to use negative 5 and negative 2. And I can use that easy way of factoring. And then on top, I have x minus 4. So I notice that nothing crosses off, which doesn't really matter when we're doing the excluded values. So I'm going to take x minus 5 times x minus 2, and I'm going to say, okay, neither of those can be equal to 0. So x minus 5 cannot be equal to 0, and x minus 2 cannot be equal to 0. So x cannot be equal to 5 because here we add 5 to both sides. And here we add 2 to both sides, so x cannot be equal to 2. So those are my two excluded values, that x cannot be equal to 5 and x cannot be equal to 2. Okay? All right, so next let's take a look at, whoa, where did my bat go? Miss Humbert, you're so silly. Okay, so let's take a look at this last one down here, and I'll drag this guy over. So for our last problem, we're going to set up the x. So we're multiplying to a negative 40 and adding to a negative 6. So that's going to be negative 10 and positive 4. So what I'm going to end up having is x minus 10 divided by x minus 10 times x plus 4. So those x minus 10s will cancel out. And when they cancel out, you end up getting 1 divided by x plus 4. Again, that top isn't going away. However, when we go to find our excluded values, we need to set that denominator equal to 0 before we simplify. So x plus 10 times, or x minus 10 times x plus 4 cannot equal 0. So x minus 10 cannot equal 0, and x plus 4 cannot equal 0. So let's go ahead and let's just solve it. So here we're going to add 10 to both sides. So we get that x is not equal to 10. For this one. Here, subtract 4 from both sides, and we get that x is not equal to a negative 4. So that's our final answer for number 9. Taking a look at number 10. Again, we're going to set that up to factor on number 10. So when we factor it, we're going to multiply to 56 and add to 15. So that's going to be 7 and 8 that multiply to 56 and add to 15. So I have x plus 8 on the top divided by x plus 7 times x plus 8. So my x plus 8s are going to cancel out. And then I'm left with 1 over x plus 7. However, when I go to find my excluded value, I need to use that original. So I'm saying x plus 7 times x plus 8 cannot be equal to 0. So then I need to take each factor and say, okay, x plus 7 cannot be equal to 0, and x plus 8 cannot be equal to 0. So here, subtract 7 from both sides, and you get that x cannot be negative 7. Here, subtract 8 from both sides, and you get that x cannot be negative 8. So you have negative 7 and negative 8 for your excluded values. So that concludes your note video for today. Go ahead and show me a completed note sheet when you are done. Thanks for listening.